Hello my math friends, welcome to a brand new series called Our Path to Mastering Mathematics, where you and I will study all types of math topics, more on the scale of undergraduate college level math. And so we will begin our study with college algebra. It is taken by most college students regardless of what their majors are. And I think that it's important to start with college algebra because it serves as a base for more upper division math courses. So we will begin our discussions on graphs. So that's the first topic. In this video, we will plot points in the rectangular, or you can call it the Cartesian coordinate system. We will graph equations in the rectangular coordinate system. We will use a graph to determine intercepts, and lastly, interpret information given by graphs. So I want to start with a quick background on a French mathematician and philosopher, René Descartes, who was born in 1596 and passed away at 1650. René developed a new branch of mathematics, which combined algebra and geometry in a unified way. A way to visualize numbers as points on a graph, equations as geometric figures, and geometric figures as equations. And so he developed this new branch of mathematics called analytic geometry. And we can see Descartes' idea called the rectangular coordinate system, or in his honor, the Cartesian coordinate system. So this is what the Cartesian coordinate system looks like, and from now on I'm just going to refer to as the Cartesian coordinate system. You can call it rectangular coordinate system, it doesn't matter. So this is what the Cartesian coordinate system looks like. We have our XY plane, which is part of it. So here we have the first quadrant, we have the second quadrant, the third quadrant, and the fourth quadrant, and in the middle, like right in the center of that, where the X and Y axes intersect, that's the origin, 0.00. So we're gonna first talk about points in ordered pairs. So each point in the Cartesian coordinate system corresponds to an ordered pair of real numbers, x, y. So for example, we have the points 1, 1, 0, 2, and negative 10, 20. And so to plot these, or to find these points on the coordinate system, the Cartesian coordinate system, for example, 1, 1, we would start at the origin, 0, 0, and our x value is 1, so we will move to the right, positive 1, and our y is 1 as well, so we will move up 1 unit to 1, and so we're at 1, 1. And you can do that for 0, 2, the point 0, 2, and the point negative 10, 20. And so here's an example of plotting 2 points on the Cartesian coordinate system. Plotting negative 5, 3. So we will move to the left 5 units because it's negative, so we're going in the negative direction. And our y value is positive 3, so we will move up 3 units. So we're at negative 5, 3. And then to plot the point 3, negative 5, our x value is positive, that's 3, so we will move to the right 3 units. And then we will move down 5 units because we have a negative 5 for our y value, and that's negative, so we will move in a negative direction, so we will move down 5 units. So that's just a quick brief idea of what points and ordered pairs are. So we will now talk about graphs of equations. So a relationship between two quantities can be expressed as an equation in two variables. For example, y is equal to 2x. So when the x coordinate is substituted for the x value, and the y coordinate is substituted for the y value in the equation, we obtain a true statement. For example, let's consider the point 1, 2. and we have this equation y is equal to 2x. So when we plot the point 1, 2 into the equation, so we would get, so for y, from our point 1, 2, the y value is 2, so we will put substitute 2 into our y, so we have 2 is equal to 2 times, and then our x value, which is 1, and that will be 2 is equal to 2. That's a true statement. So next, I want to talk about a method for graphing such equations on the coordinate system, and that's just called the point plotting method. There are other methods as well, which will be covered in future videos. So first, in order to plot points on the coordinate system, we will first find several ordered pairs that are solutions of the equation. Then you will plot these ordered pairs as points in the Cartesian coordinate system. And lastly, you just connect the points with a smooth curve or line. And this will give us a picture of all the ordered pairs that satisfy the equation. And I will provide an example of that later on in this video in the review section. So next is intercepts. So we will discuss the two intercepts, the x-intercept and the y-intercept. An x-intercept of a graph is the x-coordinate of a point where the graph intersects the x-axis. So for example, we have the equation y is equal to 4 minus x squared. The graph intersects the x-axis at -2, 0, or sorry, points at the point -2, 0 and the point 2, 0. So the x-intercepts are -2 and 2, and then the y-coordinate will corresponding to the x-intercept is always 0. And then as for the y-intercept, it is the y-coordinate of a point where the graph intersects the y-axis. So we're going to use the same example, y is equal to 4 minus x squared. So the graph intersects the y-axis at 0, 4. And so for our y-intercept, that is 4. And then the x-coordinate corresponding to a y-intercept is always 0. So I have an example of different types of intercepts that we have here. So for, looking at this first graph, we have a curve that intersects the y-axis. So there's only one y-intercept. It does not touch the x-axis, so there are no x-intercept. And then the second one, we have a curve that touches the x-axis at one point. So we only have one x-intercept, but we do not have any y-intercept because it doesn't touch the y-axis. For the third one, we have this circle curve here. It does not touch the y or the x axes, so therefore there are no intercepts. For the fourth one, we have this curvy S line. So it touches the y-axis at 3 points. One's right there, the other one's right there, and then the last one's right there. So there are 3 y-intercepts, and it also touches the x-axis at 1 point. So we only have one x-intercept. So lastly, we have this curve right here. This is a parabola. Y is equal to x squared. And here it touches the both y and x axis at the origin. And so we have the same x-intercept and y-intercept. And so lastly, for this video, we will talk about interpreting information given by graphs. Graphs are very important. You will likely see graphs in almost every math classes you'll take. And they're extremely crucial in real-world applications. And so we're going to look at line graphs, which are often used to illustrate trends over time. Some measure of time, such as months or years, frequently appears on the horizontal axis. and the amounts are generally listed on the vertical axis, so your y-axis. So we have an example of a graph that shows a linear relationship between Celsius and Fahrenheit temperature. So using this graph, let's convert or find what the Celsius of 70 degrees Fahrenheit is. So looking at this graph, if we go along the x-axis, the temperature in Fahrenheit, and we find 70 degrees Fahrenheit, and then we go up to where the line, the linear line, the line that touches or crosses at the point 70, and it looks like the temperatures in Celsius is about 22 degrees Celsius. Alright, so here's how you do number 1, which states plot the points 3, 5 and negative 2, 6. So here I've drawn the XY plane here, and I already labeled my X and Y axes, and then the origin 0, 0. So to first plot the point 3, 5, I'm going to start at the origin. Actually, I'm just going to use a different color. I'll use blue. So I'll start at the origin, and then I'm going to move to the right 3 units because it's positive. So 1, 2, 3. So actually, I'll just draw it. There you go. And then I'm going to move up 5 units because 5 is positive. Around there, I guess. And so that's the point 3, 5. And so next, to plot the, I'll use green actually. The point negative 2, 6, I'm going to go to the left 2 units because we have a negative number, a negative x value. And here I can just label this. This is x, y, this is x, and then the y coordinate. So actually, I don't know if you can see this green. I'll just use pink, I guess. So here I start the origin and I go to the left 2 units actually. It's negative 2. Alright, and then our y value is 6, so that's positive, so we will move up 6 units. So around there. And that's the point negative 2, 6. And there you go. Alright, so for number 2, it states graph y is equal to 4 minus x for x is between negative 5 and 5. And so for this one, you can start with creating a table and then write your ordered pairs and then graph them on the xy plane. So that's what I'm gonna do. So I'll just do it right. I'll do it right here. All right, so I created the table right here. On this left, I have the x values, and then on this right column, we will have the y values. So we're gonna start with negative 5. And so we're gonna plot, so y is equal to 4. Sorry, my pen wants to work. There we go. 4 minus, and then plot our x value in. So that'll be negative 5. And so that would just be 9. The negatives cancel out, so that's 4 plus 5, so that's 9. Next, a negative 4. So y is equal to 4 minus, and then negative 4. So that's just 8. Lastly, actually no. 4 minus 4, that will be 0. And then 4 minus, oops. Sorry, my pen is not working well. 4 minus 5, that will be negative 1. Alright, so that's, so this, I'll just write this order pair. So this will be point negative 5, 9. And then you can figure out what, like combining them together. And so next we're gonna plot these our xy plane. All right, so I've drawn the xy plane here. So we're gonna go back and look at our table. We're gonna plot the first point, -5, 9. So we're gonna go down here. So -5, 9. So we're gonna go to the left 5 units. So this is gonna be 1, 2, 3, 4, 5, and then 9. Positive 9, I believe. Yeah. So we're gonna go up 9 units. So this is gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're gonna be around here. And then next is -4, 8. So it's not too hard. You just go down. And then you just continue and it'll be like a line. Alright, so this is what it looks like. Sorry, it's not the best drawing, but you can see we have a negative line, or like a linear graph here. A negative linear graph. So this is the y is equal to 4 minus x. Alright, so for the last question, identify the x and y intercepts for these 4 parts. So for part A, we have this graph here. And so the x-intercept would be at the point -1, 0. And then for the y-intercept, that would be at 0, 2. For part B, we only have one intercept, and that is the x-intercept at point 3, 0. And then for part C, we have also one intercept, and that is at the origin, 0, 0. For part D, we have 3 intercepts, 2 x-intercepts and 1 y-intercept. The 2 x-intercepts are at point -2, 0 and 2, 0. And then our y-intercept is at point 0, -3. Alright, thank you guys for watching this first video of this new series on mastering our path to mastering mathematics, where I'm starting with college algebra. So in the next video, I will be doing more practice problems on this section, and then we'll move on to a different topic.